So the next topic I want to talk about is ordering. You might want to say sorting, but ordering, I think, is a more appropriate way to describe it in this context. In general, and this is a very kind of obvious statement that I'm about to make, performance of querying a lakehouse table will be optimized when the rows that are queried together are close to each other. Right? And by close to each other in a lakehouse architecture, that effectively means that rows queried together are within the same file or a set of, a small number of files. Right? If you're querying 10 rows from a lakehouse table, I'd much rather those 10 rows come from one file than have to scan 10 files to find one row in each. Now, partitioning is absolutely one way to ensure this, and it's typically the first order of ensuring that data queried together is organized together. And we talked about date partitioning being very common. If most of your queries that run against the lakehouse table are going to filter by day, then it makes sense to partition your Iceberg table by day so that when querying that table, you don't have to scan the entire table. You can go straight to the days and find the data returned. Sorting, though, is another way to ensure that data queried together is typically found and organized together. Right? And there's an example down at the bottom. I think this also came from a Dremio example. This might actually be from the Iceberg docs. I don't remember specifically, but again, shout out to both. Is that column level statistics are stored within the Iceberg metadata. So you can define an Iceberg table that sorts by a number of columns. And when that data is sorted, these statistics that appear in the Iceberg metadata will help query engines determine which files to scan to pull back data. And a name example is a very common one, right? If we're sorting our Iceberg table by employee name, in the Iceberg metadata file, which you can see an example of down below, these column level statistics will include min and max values for each column. So if I'm querying this table to find all of the first names that start with the letter B or C, because my data is sorted by name, I know that I only have to go to file 1 to return that data, and I don't have to query file 2. Right? So it's really important in Iceberg, especially in the event that many of your queries are going to return subsets of data based on some sort criteria beyond the partition scheme, to have your data sorted by that column when it's written into Iceberg. Now, there is kind of an advanced topic as it comes to sorting. I'm not going to spend a lot of time on it because, to be honest with you, it's very complex. Again, there's some really good content out there. There's some really good content out there for better understanding both kind of Z ordering fundamentally from a mathematical perspective, as well as how it adapts into Iceberg. Fundamentally, the best way I like to describe Z sorting is it can be useful when you need to sort by multiple columns, both of which have high cardinality. All right. So think of a scenario where you're sorting alphabetically by name, and then you also want to sort by some number, like age, right? If you sort by name first, even if you're sorting by age, you're going to have a mix of sort values between, all of the different names that you're also sorting by. So what Z sorting allows for fundamentally is it allows you to ideally better group together rows of data that need to be sorted by multiple dimensions. Right? Now, in most cases that I've come across, Z sorting is probably not a good fit. I'll call it overkill. Think about how you're querying your Iceberg table. In most cases that I've come across, and this is not all cases, but in most cases, you're generally filtering or querying maybe by partition and then by one other value, in which case regular sorting should be fine. But if the query patterns that you leverage are going to sort by multiple values, especially both of which might have high cardinality, you might want to consider Z ordering. And again, without going into the details of how it works and all the statistical computation of it, the goal of Z ordering is to better group together data across multiple dimensions, using the Z ordering sort algorithms. Right? There's a lot of kind of on the Iceberg documentation and in the Dremia post that I mentioned there. There's a lot of good kind of use case driven examples of Z ordering. In other words, when to consider it. Probably the most cut and dry is that bullet that I put there. If you have multiple columns with very high cardinality that you often query for together, then Z ordering might be something to consider. If you don't, though, it's probably overkill, and it actually could affect regular sorting, right? If you Z sort when you don't need to, you may end up with an overall data set that's not as well sorted if you only sorted by a single column. So there is some negative potential if you use it when you don't need to.